In this video, I'm going to explain refraction at spherical surface, single spherical surface. Here there is a spherical surface separating two media. Here refractive index of the medium is N1. This side refractive index is N2. A ray of light is incident at the point N. So this is here, so object. Then here it is undergoing refraction and images here. Here we have to draw the normal at the point of incidence. Normal at any point will be perpendicular to the tangent. So normal will pass through the center of curvature of the spherical surface. This angle alpha, PON, angle PON is alpha, angle NCP is beta, angle NIP is gamma. Then this is the angle of incidence. So angle between the incident ray and normal. This is the angle of incidence, and the angle between the refracted ray and normal is angle of refraction. Now at the point N, let us apply Snell's law in the product form. So here it is N1. Then this angle is I, so sin I. N1 sin I is equal to, here refractive index is N2, then into sin R. So this is the Snell's law in the product form. N1 sin I is equal to N2 sin R. Now since the angle of incidence is very small and angle of refraction is also very small, so instead of sin I we can write I. Then when angle is very small, sin I will be same as I. Then sin R will be same as R. So you can write like this. Now this triangle, so this is almost, since angle is very less, you can consider almost a straight line NP. So in this triangle, we can take tan A alpha. So tan alpha is opposite side by adjacent side. So PN by PO. Then tan beta is PN by PC. Tan gamma is PN by PI. So since angle is very small, this can be considered to be a straight line. So it can be treated as a triangle. So tan gamma is Pn by Pi. Since angle is very small, tan alpha can be written as alpha. So from this we can write alpha is Pn by Po because angle is very small. Similarly, tan beta is equal to beta when angle is very small. So instead of tan beta we can write beta. So beta is Pn by Pc. Gamma is Pn by Pi. So you'll get like this. Now you take this triangle NOC. In this triangle, I is equal to alpha plus beta. Exterior angle is equal to the sum of the interior opposite angle. So in this triangle, I is the exterior angle. So exterior angle is equal to the sum of the interior opposite angle. So in this triangle NOC, I is equal to alpha plus beta. Next you take this triangle. In this triangle beta is the exterior angle. So it is equal to the sum of the interior opposite angle. So beta is equal to R plus gamma. After rearranging, you will get an expression for R. R is equal to beta minus gamma. So you are getting an expression for angle of incidence and angle of refraction, that you can substitute in this expression n1 I. So instead of I, we can write alpha plus beta is equal to n2. Instead of R, we can write beta minus gamma. So now you rearrange this n2 minus gamma, you take to this side. So n1 alpha plus n2 gamma. Now n1 beta you take to the other side, that side n2 beta minus n1 beta. So beta can be taken outside, so it can be written as n2 minus n1 beta. So you are getting this after rearranging. Now for this alpha, you can substitute Pn by Po plus N2. For this gamma, we can write Pn by Pi is equal to N2 minus N1 beta. Beta we can write Pn by Pc. Now Pn common, so after cancellation you can write like this: N1 Po plus N2 by Pi is equal to N2 minus N1 by Pc. So you're getting this expression. Then finally for this Po, we can substitute. Then as per sign convention, all the distance is measured from the pole. Then distance measured from the pole to the left side is taken to be negative. Now you see Po is minus u. So instead of Po, you can write minus u. Pi, that is V, pole to image, that is V. For this Pi, we can write V. Then for this Pc, we can write R. So in this expression, after substituting, you will get like this. So instead of Po, you can write minus u. So it is measured towards the left, that is why minus u, plus N2 by Pi. It is measured to the right, so it is positive, plus V is equal to N2 minus N1. Instead of Pc, we can write R, pole to center of curvature. So it is measured towards the right, so positive. Then you rearrange this: N2 by V minus N1 by U is equal to N2 minus 1 by R. So this is the equation for refraction at a spherical surface. N2 by V minus N1 by U is equal to N2 minus 1, N2 minus N1 by R. Suppose the first medium is air, then instead of N1, you can write 1 in this expression. Then instead of N2, you can write N. So N by V minus 1 by U is equal to N minus 1. If the first medium is air, instead of N1, you can write 1. Instead of N2, we can write N. N by V minus 1 by U is equal to N minus 1 by R if the first medium is air. So this is the general expression for a spherical for a refraction at a spherical surface. Thank you for watching.